Okay, question 3 on page 49. Difficult question. We're going to have to work through the legend. The legend is the hardest part about this type of question. Now, they've given you some information already. They've said that in absence of a dominant rose comb and a pea comb is little r, little p, will produce what's called a single comb. A little comb is that thing on top of a rooster's head there. So let's start with that, because they've actually just basically given us that genotype. If I have little r, little p, I'm going to put a little hook on my little p so I don't get that mixed up with a big P. That's going to be single. Okay? Now what they're also saying here, and they're giving us another genotype, they're saying if I have a capital R with a capital P, that's going to give me a walnut shape P comb. So if I have a capital R, doesn't matter what the other allele is, capital P, doesn't matter what the other allele is, that's going to give me a walnut. Now, let's go back and read the other bit. It says gene R produces a rose comb. So if I have a capital R, now, doesn't matter what the other allele is, it can't be a capital P. So this next one here, this can't be a capital P here because that would be walnut then. So the only way that I'm going to get a rose comb, and this is the part that you have to take a leap of faith. You're going to have to deduct this from the rest of the question. And what I mean by that is that it can't be a capital P, so it must have to be two little p's. Can't be a capital P because then it would be a walnut. That's how I get a rose. I have to have a capital R because it's dominant. But the other one, the other gene located on a separate chromosome, has to be two little p's to get a rose. Make sense? Hopefully, right? If not, give me an email, we'll go over it again. Now it says another independent gene, capital P, located on a different chromosome, produces P combs. So, must have little r's, because if one of them was a big R with a big P, again, it would be walnut. So I must have little r's with at least one big P. Can't be two little p's, because then it'd be single. It doesn't matter what the other allele is. When I have that condition, it's going to be a P comb. So a little bit of a leap there that we had to make on those last two genotypes. The other genotype, they gave it to you. They made it part of the legend there already. Okay, bit of a stretch. Email me if you don't quite get that, but you can see that when I have both of them recessive, it's single. When I have at least one of them each dominant, capital R, capital P, walnut. That's how we were able to determine that if I have a capital P with two little r's, it's a P, capital R with two little p's, rose. Okay, so now it says indicate the phenotypes of the parents and give me the genotype and phenotypic ratio of F1 generation of the following crosses. Here's the first one. So let's do the phenotypic ratio of the parent, or the phenotype of the parent first. If I have two little r's with a big P, two little r's with at least a big P, that's going to be a P comb rooster or chicken or whatever. In this case, capital R with two little p's. As long as I have a capital R and then two little p's, that's going to be a rose. Okay, so that's our two phenotypes of the parents. I'm going to do a Punnett square now. You're going to do them just like, so you can see this is polygenic, because now you have the trait for, or the allele for round does influence the P. When they're both together, that gives you a different phenotype. So there is some interaction going on between those two traits. Whereas we didn't see that when we looked at regular dihybrids. So let's fill this in. Capital R, capital P, or sorry, little r, capital P. Everything else is a repeat. So just like before, we don't show repeat gametes within the same genotype, or same parent. Now, capital R, little p. And again, make your p's very different than your big p's. I'm going to put a little hook on them. But everything else is a repeat. Okay, so when that's the case, we've taken a 16 Punnett square, broke it down into one. Gives us so much time. You're going to see that if you don't do these shortcuts, there can be the risk of running out of time for some of your exams. So now we're going to bring the, I messed up, this was supposed to be capital R. So now we're going to bring the R's together, we're going to bring the P's together, right? To simulate fertilization like we've done before, show the dominant allele first, capital R, little r. Capital P, little p. And take a look at our legend. As long as I have a capital R, a capital P, that's always going to give me walnut. Now this is showing one offspring, but the reality is that these two parents can have tons of offspring, let's say 30, 40, but all of them, 100% of them, are going to be walnut with those two parents. Okay, pretty complex. Any issues, give me an email. Thanks, guys.